All right, so hi, I'm Franz Pear with Skyline, and today we're going to dive into the basics of Git and the do's and don'ts of Git security. So let's start first with what is Git? Well, Git is an open source version control system that stores data in a repository. So some other examples of this might be Subversion or Mercurial. It's used very frequently to manage code projects. So if you've got a lot of different developers working together, Git is a very helpful tool for everyone to manage their own versions. And what's really useful about Git is number one, it keeps full version history. So that means if you all are working on a project together and you need to go back to a version from like 6 months ago, Git has all of that full version history, so you can go back and access it very easily. Or if you accidentally deleted something, you can get it back. So that's very helpful. It uses a system called with commits. Basically, these are just snapshots. So as you are developing your project, you are taking a snapshot that's called a commit, and that is stored in a repository. This system also allows for concurrent editors. This is very unique for version control systems for its time. Now it seems to be pretty common, but before it used to be that one person would have to check out a file. So they would say, I'm working on this file. No one else touched this file until I'm done with it. Instead of doing that, Git actually allows people to edit the same file at the same time, but because people are editing it on their own computer and they're doing it locally, this means that there's a merging process. So at the end, when the files have to be at the end when the two different versions have to be combined back together, there's a process to take the modifications from both versions and combine them together. That's called merging, and that is when if there's any like conflicts, they're addressed then. And a cool thing about Git as well, I kind of alluded to it already, it can be run without a server. So almost all of the operations are local. And what you can do is actually take your version of the repository and you could just do it like run it completely from your computer without a server. Or if you're working with multiple people, you can actually peer-to-peer pull updates from someone else's Git repository, and vice versa. If you want to give them a copy of your version, they can actually pull from you if you've allowed that connection. So Git is very, very common in coding, and it's a very powerful tool. Now, let's take a look at this in action so you can kind of visualize it a little bit better. So I've got a small example here of how Git works. These blue dots that I've got, they're just the snapshots. And as we're going from left to right, this is the timeline. So as we go to the right, we're getting closer to current time. And what you can see here is that we've got this gray line that's going all the way across, and that is the main branch. So that is basically the like current version of our repository, the whatever like everyone in our group is using as the official version. And then when Alice wants to work on some new feature number 25, she will create a new branch. So she'll create her own version of this repository. And that's this orange line right now. Now, as you can see, time is still going on. So Alice is taking a couple days to work on her new feature. And as she's working on this new feature, other people in the company, they are writing their own code, and they're merging that code back into the main branch. So while she is working on her feature, other people are still making new commits. And so what needs to happen here when she's done with her feature is that she has to merge it back in. And that's where you see the orange line connecting back into the gray line. So there's that merge process where she needs to go and commit all of her changes and then merge it with the main branch. At that point in time, if there are any situations where, hey, these two files were edited by like these two files were are different versions, they were edited in both branches, that needs to be resolved. And then Alice's work gets merged in. At the same time, we've got Bob here in the green. He's trying to fix a bug. And you can see here, it takes him a couple days to fix that bug. He starts his branch after Alice does. And he also merges his branch back in after Alice does. And so what ends up happening here is that Alice's changes have to be reconciled with Bob's changes, as well as Bob needs to reconcile any other changes from these blue dots on the gray line when he goes to merge in his branch back into the main branch. So this is just a quick diagram to show how it works. Basically, all you need to know is that you've got these different snapshots that are called commits, and for people to work on the same project at the same time, they're just creating their own copy of the repository. They're branching off of the repository, and then they're making their changes. And then when they're done with the changes and they want to bring those changes back into the main project, then they have this merge process, and that kind of completes the cycle. And so at large development teams, you might have dozens or hundreds of people who are creating their own branches off this main branch, and then eventually going back and merging them all in. Now, we're here not necessarily to be developers. Of course, that's very useful in security, but we're looking at what are the security implications with using Git. So the number one security implication with using Git is that people might accidentally save sensitive information in the Git repository. And when you do that, everyone who has access to the Git repository can see that. And this is especially problematic if you are using some sort of public online service to host your repository, such as GitHub or GitLab. And this makes you susceptible to someone just looking up your project to find your secrets. Maybe those are login credentials or API keys, things that actually an adversary could use to impersonate you or to take advantage of your credentials. And this can be done by, even if you don't think that you're a big target, this can be done by anyone through something called Google dorking. Now, if you're not already familiar with that, I would recommend that you check out our information on open source intelligence. But basically, Google dorking is a technique where you run very, very specific queries on a search engine like Google to help you find specific information that is of particular interest to you. In the case of Git, it is very possible for people to run Google dorks, which will specifically look for anyone who has a public repository that matches whatever their search criteria is. Maybe they're specifically looking for secrets. So let's take a look at these. And I would also recommend, if you are looking for examples of Google dorks, I've got a couple here, but check out exploit-db.com. They've got plenty of Google dorks. I always go there when I need to get some ideas for Google dorks. I usually don't write very many of my own. I usually take something that's already existing and then make some modifications if I need to run a Google dork. But I've got 4 examples that I've pulled from the exploit-db.com website. And this very first one, it is just searching for any Git repositories that are publicly available. So just anything that you can go and clone. This .git folder is used to store all the information for the Git repository. And so if you search for a web page that is an index of web page, so any web page that has a full directory listing of everything on the server, and then there's also a match for a .git folder, there's a good chance that's a repository that you can then clone. This is the next one here is to just find any secrets. So we're searching for any text file on any GitLab repository which has the text secret in there. You can swap in whatever else you want to search for, but in this case we're searching for secret. The next example here, we're searching for website logins. Any GitLab project that has text has a text document that says password and matches these at gmail.com or at yahoo.com. So we're looking for login credentials basically. And this last one here is specifically looking for Windows login credentials on GitHub. So these are some very basic Google dorks. I'll show you all how they work in the demo, but keep in mind that these are just 4 examples. There's a ton of them out there. You can make your own as well. But basically what you want to make sure happens from a security perspective is that when you're using a Git repository, you don't want to have it be the case that someone can run one of these Google Dorks and find your repository and steal your secret keys. You really do not want that happening. And I'll give you a quick little set of do's and don'ts here to help you prevent this from occurring. So number one is just don't commit sensitive data at all. That's just like the safest way to do it. If you need an API key for your service, then don't save it in like a .config file. If possible, you want to use environment variables where you store it as an environment variable, or if you use a config file, do not commit it to your repository. So you can use a .gitignore file, which will specifically tell Git to not save specific files to the repository. You need to do that so that you don't accidentally put in your API keys or your login credentials into the repository. Because again, anyone who has access to that repository will have access to that information. Number two, don't host private repositories with public share settings. This is basically how everyone gets pwned all the time. It's because they mess up these first two tips. They commit something that they shouldn't be committing, like some credentials, and then they accidentally share that publicly online, and now anyone from the internet can go and get it. It happens a lot where people are sharing their repository on GitHub, because GitHub also allows for private sharing. You can have private repositories where it's only you and whoever you want to have access to it. However, you have to make sure that you enable the private repository setting. If some people forget that and they leave it as public and they don't realize that anyone on the internet can go and access it. So keep that in mind. Not only are you risking your credentials, but if you are working on some sort of company project, you're also leaking all of your proprietary code as well. So there's more than just credentials at stake here. There's the actual source code itself. And the last tip here is, if you do accidentally commit some sensitive data, then make sure that you are removing it correctly. So I mentioned that Git does snapshots. So what happens is that if you delete a file between snapshots, it is being deleted in the subsequent snapshots. But if you roll back the history and you go back to a previous version before that sensitive data was deleted, it's actually possible for someone to go and retrieve it. So if you do accidentally commit some sensitive data, make sure that you're using some sort of specialized tool like filter repo to go and purge all of that sensitive data in the previous commits, so that there is just no record of it whatsoever. So that's all very important. All right, so let's go into some very basic GitHub actions, Git actions. So number one here is to create a new repository, git init. This is a command line tool that I'm using. There's also a GUI version of Git. There's plenty of GUI versions of Git actually, but for these examples, I am using the command line. So git init to create a repository. Git clone lets you make a copy of a repository. You can clone from a remote destination as well. That's how you use things like GitHub to pull a repository from a remote location. If you want to take a file and the modifications from that file and add it to staging, meaning that you want to add it to the queue to be committed in the next commit, you do git add and then the file name. To actually go and take everything in staging and save it, you do git commit. If you want to switch between the different branches, you can do git checkout to switch between branches, git branch to create the new branch. And then if you need to roll back to a previous commit, git revert, and then you give the reference to that commit. So we're going to take a look at some of these features in our demo today. But I promised you all that we were actually going to go and look at a Git repository and find some hidden secrets. So I believe it is time for the demo. Now I'm going to go and get us set up with our demo environment. The first thing that we're going to do is try out some Google Dorks to show you what that looks like from an adversarial perspective and what you're putting at risk if you don't secure your Git repositories correctly. And then we're going to take a look at a Git repository and try to extract that information. So I'm just going to go and switch over to the demo. And I've got my my trusty Google over here, and I'm just gonna copy and paste some of those previous Google Docs that we had in the slides. If you have any questions, by the way, as I go through this in the live demo, go ahead and leave it in the chat. I will try to answer it when we finish the demo. All right. So the very first thing I'm going to do here is run this Google Dork that is searching for Git repositories that we can copy. So we're just searching for any index of pages that have a /.git. So this is some repository for High Street Consulting. I have no idea who these people are. All right. These definitely look like some consultants. I don't know if there's some sensitive information in here, but it's available publicly for anyone to access. There's a GitHub repository from vaughan.edu. Again, don't know if this is sensitive or anything, but I can actually see this is a Git repository from 2016. So someone published this here. Now, just looking for Git repositories isn't particularly interesting because you're going to find a ton of them, and most of them are going to be like empty and not very interesting. So let's search for something else. And keep in mind that there are a ton of false positives that you're going to get when you're doing the Google dorking. So sometimes you might need to dive in several pages in the search results before you get anything that looks interesting. So I'm just going through and clicking some of these links. All right. So this looks like someone's personal project. Maybe this is a fork of a repository. And it looks like they've forked. Yeah, it looks like they forked some project. So what we're seeing here are like the default credentials. Not particularly interesting. Looks like these might be some API keys of some sort. Someone published. These look like default credentials. So again, I have no idea if these are defaults or if there's something here that's actually sensitive, but just by doing this quick Google search, we're at least finding things that would be interesting to investigate further. If you're specifically doing reconnaissance on a target, well, then you can add some additional filters to be more precise. So if you know the name of the repository, if you have their domain name, you can specifically go and search for any Git repositories on their domain. All right, let me do one more Google Dork, and then let's move on to actually going through a Git repository. All right. So it looks like this is a README file with some passwords. I'm going to assume that these are not sensitive because it isn't a README file. Oh, it looks like someone left their username and password to log into a SMTP server. So this is their email. This is their email login. Yeah, this is why you do not want to commit any sensitive credentials into your Git repository. Hopefully this is no longer the password, like the username and password that they have. It looks like this was committed 3 years ago. So yeah, I hope you updated your password. But their password is publicly on the internet because it's committed into the repository. I'm actually curious if I look at the current version of the repository if it's still there or if they tried to delete it. So I'm looking for new web. Yeah, it looks like they tried to delete this. So they tried to delete this commit, it seems like, but it's definitely still there. Definitely still have the login credentials. All right, so let's now go into trying a real world demo. I've got our practice environment on the Cyber Skyline platform. We are going through one of the gym challenges in the forensics category with it's called version control, and this is the Git backup. So I'm going to actually sync this file over to my command line over here. And I've got this zip backup, this git backup.zip. I'm going to unzip that. All right. All right. So we now have our README document from this Git backup, and I'm going to go look through these questions to figure out what we're trying to do. So a computer is compromised. We have this backup file, and we have to figure out what information was stolen. We have to figure out the email address of the employee who was compromised. So when I do an ls, all I get is this README. If I look at the README, it doesn't have anything useful in here. But if I do an ls-al, I can see here there is a .git folder, which indicates that this is a Git repository. And so if I do a git log, what this will do is show me the commit history, and it'll actually tell me who the authors are of each commit. So I can see here that Greg Peterson with this email address made a commit on February 12th. And what I can actually do is just copy and paste his email address, because that's the first question here. So it looks like this is Greg's repository. There's only 3 commits right now that we're seeing, and they're all from Greg. And so I'm going to submit his email. And so we've got that correct. The next one's asking for the flag that was compromised. So just judging by this commit history, we can see here, first thing that happens is this initial commit. Then after that, there's a commit that says backing up data. And then there is a final commit that says, oops, wasn't supposed to commit that. Sounds like Greg here went and tried to delete something that he added in this previous commit. So there are 2 ways that we can try to figure out what that is. The first thing we can do is run a git show. Git show will give us details about the commit, the specific commit that we pass in. So if I copy this, yeah, the one that says, oops, wasn't supposed to commit that, I paste this in here. And I can see that a flag.txt was deleted. So if I go to the commit that says backing up data, I do a git show on that. Now we've got a flag here. So there we go. That was pretty simple. Git show is giving us the diff. So this is what was the actual contents of what was added between the 2 commits. So from the initial commit to this commit that says backing up data, this is the text that is added. And then when we did the git show on the previous, on the last commit that says, oops, wasn't supposed to commit that, we can see here, delete file mode, and then a removal of flag.txt. Another way that we can go and retrieve this, I mentioned that we can roll back. So if I get the commit here for the data backup, and I do git checkout, I can actually go and check out to this specific version. So if I do git log, you can see here that the oops wasn't supposed to commit that is missing from our log. We actually just went back to this specific commit. And what we have is this flag.txt. And if I print that out, that is the flag that we are looking for. All right, now the question is, and sorry, my head is probably blocking this. The question is saying that Greg thinks that he may have had additional account credentials that were compromised. What's the name of the service provider for the other compromised accounts? So far what we've done is we've looked through the commit history, but only in the default branch. So if I type in git branch, you can see that we're now actually on this this new branch because we did this git commit on that specific commit, which did that revert. And so now we're not part of the main branch anymore. So we need to get back to the main branch. And so now we're back on the master branch, and we can see here that there's also a next branch. We haven't taken a look at that yet. So I'm going to do git checkout next. Now this is switching me back to the next branch. And if I do a git log, just to see what's going on here, we can see that there's a commit for backup passwords. So this is different. We didn't see this in the previous branch. All right, so let's do an ls. And we can actually see here, there's the passwords.txt. So if I just print that out, we've got, looks like a Facebook password. So the service provider then would be Facebook. And then the password will be waffles 85. And now we're done. So hopefully that wasn't too complicated. Basically all we did was just switch between different branches and then checked out a specific commit. And that's like the basics of trying to recover some sensitive information from Git. Now, before we went and did that, we actually went and used Google to find some sensitive data on public Git repositories. And this is why it's so important to follow those 3 recommendations that I provided. Be very careful with what you're committing into your repository. Don't commit any sensitive information, no credentials, no passwords. Be very careful about your public share settings. Even if you don't commit any sensitive credentials, if you have a public repository that has proprietary code, you don't want to get in trouble if people are just downloading your source code from the internet. And then the third thing is that if you do accidentally commit anything that is sensitive, make sure that you're using the proper tool to purge that data. Or even if you delete the file, an adversary can go and revert those changes and get the original sensitive information. So doing a deletion and then a new commit is not sufficient enough to remove that from your repository. You have to use another tool to actually purge that data thoroughly. So I hope you found that helpful, and thanks so much for joining. All right.